Question number 31. A battery with a constant internal resistance is connected to a resistor of resistance 250 ohms. Okay. The current in the resistor is 40 milliampere for a time of 60 seconds. The current here is 40 milliampere for 60 seconds. During the 6 joules of energy is dissipated by the internal resistors. Okay. So here 6 joules of energy is dissipated. What is the energy supplied to the external resistor during the 6 seconds? What is the energy dissipated here? Okay, let us find out that. So energy and the electromotive force of the battery. He is also asking you EMF of the battery. So first one is quite easier. How? It is nothing but I squared R into T. I square R is power, T is time. Power into time is energy. So we can find out the energy here, which should now be equal to, what is I here? 0.04. How? 40 milliampere is nothing but 40 divided by 1000. See, 4 by 100 is 0.04 whole square multiplied by 250 multiplied by 60. Calculate this value. And what do we get here? We get 0.04 star 0.04 into 250 into 60. When I do this, I get the answer is 24 joules. 24 joules. Do I have any 24? Oh, I already have 24 over here. These two are incorrect. So among this one I have to choose. Then I need to, okay, now if this is 24 joules over here, I need to find what? EMF also. This 24 joules over here, add this one also here. 24 plus 6 is equal to 30 joules. Now, how is this useful if you ask me? Okay. So what is this now? This is nothing but the total energy given by the battery. Total energy given by the battery, which drives a charge or an electron, okay, so that it comes back to the circuit. Okay, this is total energy spent by the battery. We know energy spent by the battery can be written as Q times V. What is V? Potential difference. Which potential difference? Potential difference across this over here, right? So you can do this, and thus I can find out this value of V. V should be equal to E divided by Q. But what is the value of Q? Can I substitute the value of Q as 1.6 into 10 power minus 19? No, don't do it. Okay, because 40 milliampere 60 seconds is given, right? So I can find out the Q from here. So the value of Q here is Q should now be equal to I into T, because Q by T equal to I. Q is equal to I into T. So this should be 40 milliampere is 0.04 multiplied by 60 seconds, which is equal to how much? It should be 2.4 coulomb. 2.4 coulomb. So now let me substitute all the values over here. So when I do this, I get this as 30 divided by 2.4. When I do this, is my calculator. 30 divided by 2.4, I get this is 12.5. 12.5 volt. 12.5 volt. 12.5 volt is D over here. Okay, so D is the right option. So you can always ask me, see this V, we call it as potential difference, terminal potential difference, but here we are asked about EMF and so on. Okay, but you know, by definition, where do we get this energy? Who gives me the energy? EMF of the cell. Okay, so therefore the notation, see, I have used this as V over here and not E here. Reason is because I already have an E here, right? This E is nothing but energy. I told you this is the energy here, so I did not use this E here. It will confuse you. You will sometimes, some students might cancel these two and say, okay, 1 should be equal to 1 by Q. What is this? I did not understand, right? So what I did was, I took this as V. In fact, this V is nothing but your EMF only, and not the terminal potential difference. Remember, there is a difference between terminal potential difference and EMF. EMF is nothing but the energy which has been given out by the cell per unit charge. Okay, so you take an unit charge and the unit charge starts driving from one end to the other end. Okay, this is because of the EMF. Terminal potential difference is you find out, you take a multimeter or a voltmeter, take the battery, put it across those two and find out what is the voltmeter, the voltage that you record there. Okay, so experimental value of the EMF of the battery is nothing but your terminal potential difference. Right, let me move on to the next one.